Hey guys, it's me, Miss Doolittle. So today what we're going to work on is how to come up with a solution of two equations using substitution. Okay, so this is systems of equations using substitution. So this is a special case, I guess, when they actually give us one of the variables. So as you can see here, they already tell me x. They're telling me x equals -3. So that kind of makes it pretty easy for us. They already give us one of the ordered pairs, so I'm going to write my solution down here, and already in my x spot, I'm going to write -3 because I already know the answer for x is -3. They told me that. So now all I need to do is I need to solve for y. So what I'm going to do is I'm going to take this value of -3 and I'm going to substitute or plug it in for x, meaning instead of writing x, I'm going to write -3. So watch me do that. 3. Now again, instead of writing x, I'm going to write times -3 minus 2y equals -9. Now all I'm going to do is I'm going to solve for y. So what is 3 times -3? Well, that's -9 minus 2y equals -9. Now I'm just going to solve for my variable by using inverse operations. I'm going to add 9 to both sides, which leaves me with -2y equals 0. Then I'm going to divide both sides by -2, giving me y equals 0. So now I have my solution. -3, 0 is the point where these two lines intersect. All right, come and see me. All right, next kind now is when both variables are isolated. What this means is that it already gives me what y equals. So I'm just going to take this value and substitute it over here for y. So instead of writing y in this spot, I'm going to be writing 2x. So right there, I'm going to write 2x equals -x plus 3. So I'm plugging 2x in for y. Now I'm just going to solve for x. I'm going to add x to both sides. So 2x plus x is 3x equals 3. Divide both sides by 3, leaving me with x equals 1. All right, now I have one spot. Now I know what x equals, but I need to find what y equals. So I'm going to take this value for x, and I can substitute it into either equation, whichever one I choose. I think the first one's going to be easier. So instead of writing x now, I'm going to substitute the value of 1. So y equals, well, what's 2 times 1? Because I plugged in 1 there. Y equals 2. Great. Now I can have my solution because I found my x value, and I also find my y value. So the solution to this problem is 1, 2. 1 being my x value, 2 being my y value. This is the solution to the system. This time, we only have one variable that's isolated. It tells me, as you can see, x is alone. X equals 3 plus y. So since that's the variable that's already isolated or alone, that's the one I know I need to substitute or plug in. It tells me x is equal to 3 plus y. So instead of writing x, I'm going to write 3 plus y. Start solving over here. So 2, and again, instead of writing x, now I'm going to write 3 plus y. And then I'm going to keep going with my equation. Minus y equals 12. I'm going to do the distributive property. I'm going to do all the steps now to get my y by itself so that I find my y value. 2 times 3 is 6, plus 2 times y is 2y, minus y equals 12. I'm going to combine my like terms. So positive 2y minus y is 1y. So 6 plus y equals 12. I'm going to minus 6 from both sides of my equation, so y equals 6. Now I have one part of my ordered pair, but to have a solution I need the x and the y value. So now I'm going to take this 6 and I'm going to plug it into either equation. I think it would be easier to plug it into this equation here. So instead of writing y, I'm going to substitute the value 6. All right, so let's do that over here. So x equals, well, 3 plus, what value did we say it was? 6. So x equals 9. Now I have my ordered pair, which is the answer to this solution. So the final answer is going to be my x and then my y. My x is 9 and my y is 6. So 9, 6 is the solution to this system. Last one, this is where when no variables are isolated, meaning it doesn't say y equals or x equals. I need to make it look like that. Okay, so what I'm going to look for, whichever one I think is the easiest to get isolated. As you can see, this y value is the only one without a coefficient, the only one without a number in front of it. So I think that one is going to be the easiest to isolate. So I'm going to rewrite my problem, 2x plus y equals 7. And now to get my y by itself, I'm going to have to minus the 2x and move it to the other side. Now y equals negative 2x plus 7. This is great. Now I have a variable by itself. Now I can substitute this into y because it says y equals into the other equation. So instead of writing y there, I'm going to write negative 2x plus 7. So watch as I do that. So I'm going to rewrite the whole equation. 3x minus 2. And again, I'm substituting negative 2x plus 7 equals negative 7. Okay, now I'm just going to go through the process of solving for a variable. So I'm going to do my distributive property, my combining like terms, all that stuff. 3x plus 4x minus 14 equals negative 7. I'm going to combine my like terms. 7x minus 14 equals negative 7. I'm going to add 14 to both sides. 7x equals positive 7. Divide both sides by 7. And then x equals 1. This is great. Now I have my x value. But to get a final answer, I also need to have my y value. So I can take this x and I can plug it into right here into this equation. I can plug it into x over here. I can plug it into x over here. It doesn't matter. I can plug it into any of those spots. I'm going to choose this equation because I think that one's going to be the easiest. So y equals negative 2. And again, instead of writing x, I'm going to write 1. Because x equals 1 plus 7. All right, so y equals, well, what's negative 2 times 1? Negative 2 plus 7. So y equals 5. So the solution to this problem is where the 2 points intersect, which is going to get me my x value we said is 1, and my y value is 5. All right, if you need help with any of this, come and see me.